So in this lecture, we're going to explore using Netbeans. In the past, you may have used Netbeans but not exploited some of the things that we're going to show. Or perhaps you have edited Java files with another integrated development environment like Eclipse, or used TextPad or Notepad to generate your files, and maybe you were compiling from the command prompt. So Netbeans allows you to generate your files, edit your code, create classes, build your projects, run and debug them all in one place rather than doing it from the command line or whatever. The debugger is especially useful. That will not be covered in this particular lecture. Instead, what we'll be covering is creating a project, building and compiling your project, adding classes to your project, adding an import statement, using REFACTOR. REFACTOR is extraordinarily useful. It allows you to rename classes, rename variables. You can encapsulate your members of your classes into private variables, and it'll make changes to your code. Refactoring does an awfully good job of making changes to your code, and for example, if you rename a variable, it renames it everywhere in the code that variable is used. Or if you rename a class, it renames all the references to that class, including the file name. If you rename an object name, it renames the declaration of it and everywhere you use it. You can also use it to extract code from your main body and put it into a method, which is also very useful because you can clean up your code and encapsulate all the useful code into methods, which cleans it up. We will demonstrate that. What else will we do? Once you're done with your project and you've executed it enough to your satisfaction, export it to a zip. And there's, of course, in Windows or on your Mac or whatever, there's lots of ways to compress your code in order to upload it to D2L. But since Netbeans has a zip utility built right in, then we may as well utilize it. It's nice, it's right there. And lastly, we will cover how to upload your project once you've zipped it up to D2L BRIGHTSPACE. And since you're a student here, you probably already know how to do that. It's probably completely unnecessary, and it's not part of Netbeans in particular, but we may as well cover it anyways on the off chance that you have not done this in the past. So the first thing we will cover is creating a project in Netbeans. And I'm assuming that you've already installed Netbeans, you know how to run it. So having done that, launch Netbeans. You're presented with some kind of start page or whatever. I just close that right off the bat. And you can see here that I have a little itinerary that I'm going to follow. This is obviously not part of the Java files that I'm going to create. So I want to create a new project. I do File, New Project. What I want is a Java application. You don't type anything in the filter unless you're just trying to winnow out your choices of the categories. Like if I type in APP, now I only have one choice here, where I had a bunch of choices before. So you don't type your project name there. Type your project name after you click Next. Now I can give it a good project name, like Lecture 4. Or you might want to use a number for it, or whatever, Lecture 4. Choices down here that are important is the create main class. Do I want it to create a class? And in that class, do I want it to add a main method? If I add this, then once we are done, once we've clicked finish, we will be presented with a class with a main method already provided. A template for us to go into our code. And that saves time. You don't have to remember the syntax for a main method. The other important things are, where is your project located? Now I've changed my default location to on my desktop. Yours is probably, if you're using Windows, in your username documents folder in a Netbeans subfolder. I'm going to leave it here in my desktop, and I'm going to click Finish. Note here that this is the file name, the class name that's going to be created, and this is the package name that's going to be created. All a package is it's a subdirectory inside your project, inside your source directory, where you can gather your classes that work on the same task. There's nothing wrong with having a package. On the other hand, there's nothing wrong with not having a package. And we can show the difference between those two things here. So I'm going to click Finish. And it has created my project. And inside my project, I see that there's a package called lecture 4, and I see that there's a class called lecture_4.java. So we do see that it generated a template Java file, with the main method. Now, one thing you might want to check is to make sure that the project you're currently editing is set to be your main project. So you can right-click on it, and if you have the option to set as main project, go ahead and do so. Because otherwise, some other project that you've opened recently or in the past may be set as your main project. You can tell that it's a main project because it will be bolded like that. All right, now I'm going to test it really quickly just to make sure I haven't broken anything. So I'm going to click the green arrow. And I get an error message. Very interesting. I'm going to pause this. Alrighty, that was annoying. I had to stop and restart Netbeans. And I'm going to create the project again just to walk through it one more time very quickly. You don't need to do this because you're not having the same problem I had. New project, Java, Java application, next. I'm going to give it a good name. Since I deleted the project completely, including the source code, I can give it the same file name. This is assignment_4. Yes, I want it to create the main class. Yes, I want it to finish. Then I'm going to click this little symbol up here that says clean and build. It's a hammer with the broom. We see that it made my ran, compiled. It's ready to run. It even tells us how we might be able to run it. Notice that it's creating something called a jar file. You may not have created jar files if you were building Java, if you were compiling your code from the command line. A jar file is just like an executable that can be run by Java that incorporates several different classes, one or more class files inside it. So let's go ahead and run it. I'm going to press the green arrow. That's the easy way to do it. You can also do that under the Run menu. And it ran successfully. Now, of course, it didn't actually do anything because all we have is an empty main method here. So why don't we change that? I'm going to drag that window up here with my itinerary. And I'm going to get rid of the start page. Shrink the output window a little bit. Alright, hopefully you can see this. Hopefully I've set the text large enough. I think I'm going to increase the text size, which you might be interested in seeing. But I'm going to do that very quickly, just to let you know that it's there. Tools, Options, Fonts and Colors. Right now it's set for a font size of 18. I could choose a larger font if I wanted to, like 24 or something like that. I'm going to do that just because you're viewing this on a video. It might be a little bit more difficult to do. And I'm going to make it bold, make it easier for you to see on the video, and I'm going to click OK. Alright, now that's really pretty emphatic there. I'm also going to delete some of these comments. It's always a good idea to have a comment block that describes what the program does, what the class does, and include your name and maybe the date. I would like for you to do that in all your assignments. So, it's already filled in something here, but if that doesn't look good to you, you can always change, Jeff Thompson, and you can give a description of it. This is assignment 4 that follows the video lecture using Netbeans, part 1. All right, very good. In the interest of making this code easier to see all on one screen though, I'm going to remove this comment. Don't do this. When you turn it in, I want you to have a comment block up at the top. Here's another comment I'm going to get rid of, just in order to get it all to fit on one page. And then the one that says to do code application logic here. Well, we know that the main method is where we're going to put our logic. So now I've cleaned it up. I still have this package statement here. If you're wondering what the package statement is it creates a source subdirectory under your source directory. So if we went out to the Java projects folder and drilled down into it, we would see a subdirectory. I could change the name of the package. I can get rid of that package assignment entirely. Two ways I could do that. I'm going to demonstrate both of them. One is I'm going to just delete that line, but then it's going to give me an error. There's a little red error symbol over here. Whenever Netbeans detects that there's an error in your class, it will flag it with a little red symbol. It can also flag warnings, in which case it'll be a yellow symbol rather than a red symbol. You have to fix the errors. You don't have to fix the warnings. You probably want to look at the warning just to kind of see, what it's talking about and whether you think it's a legit warning or not. In this case, incorrect package absolutely is a legit error. It will not compile correctly. The reason why is that our file is still in this subdirectory over here, but we're not telling the class that it's in that subdirectory. There's two things that we can do. One is we can move it up, or two is we could add that line back again. If we click on the error, we see both of those options there. Move the class to the correct folder, or add a package declaration back to it. So if I do that, it adds the word package right back. But instead, I'm going to correct it by moving the class to the correct folder. I could have done the same thing just by grabbing the file, which we now see in the default package directory, and moving it up. All right, so now we have a very minimalist class file here. So file save, always useful. I just tend to hit Control S. In fact, I tend to hit it a lot. Netbeans is always running a kind of compiler on your class to make sure that you're not introducing syntax errors. Like if you do this int I and then you type int j. There we have some error markers there. I'm just going to undo all this by hitting Control Z a few times, or Command Z if you're using your Mac. So that covers creating a project. Why don't we go to the next topic, which is building and compiling your project? So I'm going to pull back up Netbeans. We really don't even have any code here that does anything. So I'm going to add a print statement to it. System.out.println. Netbeans is cool. All right, now that's enough to prove that the project is going to run. Now when I build it, we're going to see some messages down here in the output window. If you don't find your output window and you want to see it, you can always find that under Window, Output. If I choose that, it's going to bring me back to it. If I had closed it, I could choose Window, Output, and it brings it back. Now it might not bring it back to where I want. It's covering the whole screen. So I'm just going to drag it down here. I like seeing my code up at the top, my output at the bottom. Your mileage may vary. I'm going to toggle back to my Java file window, and I'm ready to build it. Strictly speaking, you don't even have to build it. You can just choose Run Project, and it will build it and run it. I like to do it in 2 steps, and furthermore, I like to do it very thoroughly, which is to do Clean and Build Project, which compiles every .java file that you have added to this project. In this case, we only have one, And if you get to the point where you have half a dozen or a dozen different Java files in the same project, then you're probably going to stop using Clean and Build. So we see here what all it's done, where it copied the files to, that there's something called a distribution directory, or at least DIST, that creates a jar file. We're pretty much going to ignore this at this point because I don't want you to upload the jar file in particular. Sure, it'll be there if you zip up the entire folder, but that's not really important. I'm going to zoom in just to make this text easier to see when I run it. I'm going to press the green arrow, which means Run Project. That's also available under the Run menu. Run Project. Netbeans is cool. All right, so it worked. The other thing I'm going to do, very, very briefly, is to show you running the project in debug mode, just to let you know that it's possible. However, this lecture does not really cover that. You don't need to do this. You don't need to follow along on this, but I'm going to add a couple statements. Int I is equal to 0, int x is equal to I, system.out.println x. or maybe x plus I, whatever. Very useful code, eh? But we will compile it. We will run it. It works, but say it didn't work. Say we got the wrong answer. I can set a breakpoint on a specific line, telling the debugger that I want it to run to that point and then stop. So I'm going to click over here on the line numbers. I want it to stop on line 7. Now I'm ready to debug it. I can come up here and choose Debug Project. It will run the application to that point. And we can see that that line number is highlighted in green. And we can step through it with the buttons up here. One of them, step over, causes it to jump to the next line. And that's what I'm going to do. I jump to the next line. This one's still red because that is the breakpoint line. But the green line is the one that's about to be executed. I click it again. It says that we're just about to run the print line statement. And then I let it step over it. And it prints out that number, which is x plus I, which is correct. Now I'm going to stop debugging by pressing the red square. Or I could do that right here. Stop. So that's the debugger. Very, very useful, but we're not going to cover it in this lecture any more than I already did. So we've talked about building and running your project. You can just do that with the green arrow. It should build it automatically when you do that. If you get into some weird state where it doesn't seem to be doing what you think it should do, you can choose clean and rebuild. If your project is requiring user input, you may wind up in the case where you've actually got several versions of the project running at the same time, in which case you would want to close them all before you ran it again. Now let's show how to add classes to your project. That is a fairly simple task. Netbeans gives you a couple of nice ways to do that. One way is to just go over here to your default package or whatever package directory you've been using, right click and do New Java Class. I'm going to make a Java class called, I don't know what I'm going to call it. Let's call it Example. It's not going to really do anything very useful. That's a silly name for it. It's giving us a warning. It's highly recommended that you do not place Java classes in the default package. So it's really pretty much complaining that by removing the package statement and letting it move up into this higher level directory, that's their recommendation. I'm going to ignore it. Okay, so now we have a new class. We could add some variables to it. I'm going to add a variable called counter. I'm going to add a method. It's going to be public so that it can be called from the main method. Doesn't need to do anything. I'm just going to call increment counter. That's going to be the name of the method. All I want it to do is add 1 to the counter. So counter plus plus. And then lastly, I'm going to add a print counter method. And again, this needs to be public, but it doesn't need to return anything. Now notice when I type the opening brace, it has already added, well, no, that's not true. But if I hit enter, it's added the close brace. Sometimes I forget that, and so when I type the opening brace, and then I hit enter, and I don't notice that there's already a closing brace, I type another one. That will introduce an error when I try to compile it, saying that I have too many close braces. You just have to make sure that the number of opening braces and the number of closing braces match. Okay, now print counter just needs to call system.out.println, and let's print our counter out. Maybe we'll give them a nice message. Counter is equal to plus counter. All right, that's enough for our class. I'm going to just put this here and pause it so you can type this in on your own. Alrighty, hopefully you've gotten a chance to type that in. Otherwise, just rewind a little bit and keep that on your screen. Do whatever you need to do to get that working in your own file. Now I want to actually use that class. And I know that as an advanced Java programmer, you know how to use classes. But I'm going to go back to my main method inside the assignment4.java file. I'm going to create an instance of that class. I'm going to call increment a few times on it. Then I'm going to test it. So over here, our class was called example. So example, I'm just going to call it E, is equal to new example. We have now declared and instantiated our object. And we can pretty much refer to objects and reference variables as being the same thing. I like to call them objects. So E is our object. It is an instance of the example class, meaning that we can call those functions. I could call E.increment counter. Let's do that a few more times. Let's increment it 3 times. Great. I'm going to hit delete a few times so that I get my closing braces here. I'm also going to remove the breakpoint here because I'm not going to be debugging with the debugger anymore at this point. Now we need to print it out to see what happened after we incremented the counter 3 times. So I'm going to type e.print. Notice that you get, the pop-up list of all the methods. There are a lot of methods that we did not add to the class ourselves. But that's because every class that you create in Java is all descended from the root class called object. And these are methods that are all implemented in the object class. We really don't need to know, really don't need to use them. We care about the methods that we have added, which in this case is print counter. Just to make sure it's actually incrementing, I'm going to call increment counter one more time. E.increment counter, and I'm just going to hit return on the pop-up list. And I'm going to call print counter one more time. So I typed E.print and I hit return to choose it from the pop-up list. It's all ready to go. I'm going to rebuild it. It says build successful. I'm going to run it with a green arrow. And it says counter is equal to 3 because we incremented it 3 times. That implies that it started at 0. Add 1 to it, you get 1, 2, and 3. Then we incremented it 1 more time and the counter became 4. So we have added and called a class. We added it by coming over here to default package or whatever package we are currently in and hitting new class, new Java class, and we gave it a name. I'm just going to allow new class to be there because I'm going to delete it in a moment. Clicked finish, and then I started modifying it. I don't need this particular class, so I'm going to come up here to new class and right click on it and choose delete. I don't even need to choose safely delete, but I could because nowhere are we using this particular class. So I chose safe delete and I chose refactor and it deleted that class. And I'm going to leave this code on the screen for a little bit so you can type it in. You might want to pause this so that you can type it in your own program. One more thing that I like to do is I like to document my closing braces so that if I wind up with too many or too few closing braces, it's pretty easy to diagnose that. So I'm just going to type / end main, and underneath that for the final brace I'm going to do end class. I could even give it the name of the class if I wanted to, or I could just say end class because that's pretty clear. That way if I wind up with too many, closing braces, or something like that, I can go, oh no, I see what's going on, and I can fix those. All right, go ahead and pause your screen. Make sure that the code works. I'm going to toggle back to the example method. You could pause your screen there if there were any problems with it. This is what our example class looked like with its 2 methods. Pause if you need to. Then go back to our main method where we utilize it. Now we're going to add an import to our class. Why is that important? No pun intended. You can always go up to the top of your file and add the import manually, and that is a great way to do it. However, I'm going to show you a way in which Netbeans can accelerate that process just a little bit. It's also kind of dangerous to show you this because you might get in the habit of clicking on the little red arrow and just choosing whatever options it chooses without, giving much thought to it. Only accept the correction that Netbeans offers you when you click on the red arrow if you absolutely know it is the correct answer. If you're just kind of getting desperate and you're clicking on the red arrow hoping that it'll fix it, it's probably not going to. And I'll give you an example of that. So now we have all this code here. It really is kind of useless code. I think I'm just going to delete it all. Or I could comment it out. Let's delete it. No, I'm going to leave it here. There's nothing really wrong with having it here. But up here, above the line that says Netbeans is cool, I'm going to create a scanner, and I'm going to ask the user to type in a number. Now, normally I would need to go up to the top of the file and add the import java.util.scanner. But Netbeans is kind enough to allow us to speed that up a little bit. I can just start using it. I can type scanner. I like to call my scanner SC. You can, call it in or whatever you like. Is equal to new scanner system in. You've seen that before. Now we're getting an error. The error is that we do not have an import for the scanner class. If we come up and look here at the top, there's no import for it. We could go up there and type it. We can also come over here and click on the error, and it's got a million different choices here. The top one, add import for java.util.scanner. We do that, and presto. Our scanner class is already imported up there. We are ready to use it. Yeah, that's not a big savings in time, but when you're using other classes that you know their names, and you may not remember the exact import statement, then that could be a time saver. We're going to do that again with a different class, not the scanner class. Say we need to generate a series of random numbers. We want the random number generator class. Well, there's several different ways you can generate random numbers in Java, but the random class is, I would think, the nicest way. So I could type random, because I know the syntax, r is equal to new random. Now we have instantiated our random object, but since we do not have an import for the random class, we get an error. And right off the bat, I don't happen to remember what the import is for the random class. I could either look it up, it actually happens to be in java.util as well. But if I didn't remember that, it's nice to have the option of coming over here and do add import for java.util.random. It's also offering to do some other things, like create a class named random. I really don't want to do that. I'm not trying to create a brand new class. I'm trying to utilize the one that Oracle gives us. So I'm going to click on the arrow, do add import for java.util.random. That last option, to add a class that matches it, is actually very useful. You could start to use a class and start to define a class on the fly and then just allow Netbeans to fix it up for you. But I'm not going to do that at this point. Okay, so we have imported two particular classes. I don't even think I'm going to use a random number generator at this specific point, but I am going to ask the user to enter a number. We're going to prompt them, so system.out.println, enter an integer. Now let's declare our integer. It's going to be an int. What do I want to call it? I'm going to call it max. Maybe it'll be the maximum number. Maybe we'll have a loop that counts from 0 to the max. And I'm going to say, we could even separate that on two different lines. Max is equal to our scanner.nextInt. And of course, that's not a real reliable way of reading in and int, because what if they type in a number with a decimal point, or they type in some garbage with letters or whatever, and they'll get an exception. But just for the case of demoing NetBeans, that's certainly good enough. Maybe we'll print out what they typed. System.out.println. You entered max. All right, now we have added an import for the scanner class. We did that just by typing, just by utilizing the scanner class right here. I'm going to delete that just so that we see it one more time. You certainly do not have to follow along with this. I'm going to delete that line as well. Here is another example of it. Scanner sc is equal to new scanner. Notice I don't have the the import. I am going to allow NetBeans to create add import for java.util.scanner. And that's about enough about that. So I'll leave this on the screen. You can enter this, pause it, type it in. I'm going to pause the recording as well. So right now our code is actually getting fairly lengthy, isn't it? It's getting to be more than one page. So I've changed my mind. I am going to delete everything after that you entered statement. So I'm going to delete the utilization of that example class. So now everything fits on one screen. Hopefully you paused it and typed it all in and have run it to make sure it actually works. I didn't even test it. I'm going to press the rebuild. Rebuilds all the classes. I can't see what it's outputting down here, so I'm bring the output window up, and it rebuilt everything. Now I'm going to run it with a green arrow. It says enter an integer. Click down here on the input window, 20, and it says you entered 20. All right, very good. Ready to go on to the next topic. Using the refactor menu. As I mentioned earlier in the lecture, refactoring is exceptionally powerful because you're using the editor to perform some tasks that speed up your development. So if you have a variable named X in your program and you've used that variable 100 different times and you decide that it needs a better name, you could go up into the edit menu and do find and replace, but what if the variable was named S? You probably have S used in all sorts of different variable names, and if you did a search and replace on them, it'd take a long time to pick them out. However, you can choose that variable S and do refactor rename, and it will rename all occurrences of it. So let's give an example of that. Let's say that I do not like the name SC for my scanner. Maybe instead I want to say IN for like input. Right now I have two utilizations of that. I could just go and change it by hand, but I can also select that variable name, right click, choose refactor, then go over to rename, and I can give it a different name. Maybe I'm going to call it input. No, I'll just call it in. In's good enough. Or standard in, whatever you want to call it. I'm going to call it IN. I click refactor, and it has changed every occurrence of that variable name to IN. Now I really don't have a lot of other variables here. The only other one that is of any use besides that R object is the one called max. So why don't we rename max as well? I'm going to go over to max. I'm going to highlight it. I'm just double clicking on it to highlight it. You can also, move your cursor to the beginning of it and use the shift key in the cursors, however you like to highlight things. Right click, refactor. Do that again. Right click, oh, come on. Go up to rename and give it a new name. So instead of max, I'm going to call it, I don't know, maximum. All right. So that is one utilization of the refactor menu. Maybe you don't rename your variables that often. I'm going to show you what may be a much more useful utilization of the refactor menu. I'm going to type some code that I then want to move to a method. So here's our code. Let's say that we want a loop that is going to print from 0 to maximum and show all those numbers. So for int my I counter is equal to 0, my I counter is less than to equal to maximum, I++, this is a pretty simple for loop, put a curly brace. Now I'm going to put my print statement right here, system.out.println I equals plus I. Okay, now I'm going to run it, rebuild it. Looks like the build was successful. Going to run it. It's going to ask me to enter an integer. I have to actually come down here and click on the output window, because if I don't, then when I try to enter the integer, it's going to put it directly in my code, which is absolutely not what I want. So I'm going to undo that with Control-Z or Command-Z if you're on a Mac. I'm going to go down here and I'm going to type an integer. And I want to print out the numbers between 0 and 5, so I'm going to enter 5 here. And there it goes. Let's expand the output window a little bit. It says you entered 5, true enough. And then 0, 1, 2, 3, 4, 5. Great. Now let's say that I really don't like cluttering up my main method with this for loop, and I want to move it to a different method, which we then invoke from main. Now you could come down here, below main, and you could start typing and add in your own method, and then you could cut that code out of there and you could paste it, and then you'd realize you need to pass in maximum as a parameter, as an argument to that method. But you can also let Netbeans do the heavy lifting there. So after you've typed this in, and I'll pause it just for a second, you go ahead and pause yours and type it in. After you've typed that method in and tested it, highlight all that code, just those 4 lines, the for statement in the loop. You saw how I highlighted it. I just grabbed the cursor, click. You can also hold the shift key down and your cursor down key. That's another way of highlighting. Right click, refactor, introduce method. Now what that's going to do is it's going to remove those lines. It's going to put them in a method of your own naming, and it will add some code that invokes that method. So what are we going to call our new method? Let's just call it print sequence. That good enough? Yeah. We could choose to make it a public method or a private method. Doesn't really hurt to leave it public. And let's make it private just for grins. And I'm going to click OK. And we see that now we have a new method. Right down here, we have a method called print sequence, and our for statement and our print code is now part of that method. I'm going to make it a little bit cleaner by moving the brace down to the next line, just because that's my favorite style of bracket placement. And then if I come up here, I see that print sequence is invoked within main. So it took all that code and it moved it into its own method, and it added the code to the main method that invokes it. Let's make sure it works before we get too proud of it. It says build successful. Let's run it. Enter an integer. Let's do the same thing we did as last time. I'm going to type in a 5, and it prints 0 through 5. So the code works. Now sometimes you will do this and it'll give you an error message that it could not move, could not create the method. Maybe you didn't highlight the right number of lines, It can take a little bit of skill in order to finesse it, and if it ever stops, if it doesn't do what you think it should do, you can always undo it. For example, I'm going to highlight this line that says system.out.println and the one above it that says maximum. You don't have to do this, I'm just demonstrating it. Right click, refactor, introduce method, introduce method. I'm going to give it a name, whatever. The name doesn't matter because I'm going to undo it. Just type in a whole bunch of letters. Click OK. Now it did do it. It's valid code, but then I decide I don't like what it did for whatever reason. I just click undo, up here, or Control Z, Command Z, and it undoes my refactoring at that point. So that's a nice thing you can do. All right. Lastly, let's show how to rename a class. Now I have my old example class over here that I deleted the utilization of it. I'm going to create a new example object just so I can refactor that thing. So example, I'm putting this under the print sequence, ex is equal to new example, parentheses in parentheses, and I'm going to call the ex dot, increment counter, and I'm going to call ex dot print counter. And then I decide I hate that name example. I want to rename it to a better class name. Example is a really stupid name for a class. So right click on the class name. I could either do it from there, or I could even do it up here. Right click on it, choose refactor, rename. We want to rename it to maybe counter, because that's what it is. And I click refactor, and notice it has changed the name of the file over here. It is now called counter.java. I can confirm that by opening it up. It says public class counter. Over here in our main method, we see that it is renamed there as well. Now we didn't change the variable name, so it's still called ex, which is still kind of stupid, isn't it? Counter ex, what is that? So I may as well right click on that and choose refactor, rename, and I'm going to rename that variable to counter with a lowercase c. Okay, there. Maybe you don't like the repetition of the word counter so many times. You could give your variable a different name. But now we have shown that refactor can rename your variables. It can extract code and place them in a method. You can rename classes, and the last thing I want to do is show the encapsulation of methods, of members. You can also do this with methods of a class, turning them private. It's always kind of tedious when you go in and you create a class and you add some members to that class, you add some variables to it, and then you realize, oh, I should have made that a private class and I needed to add getters and setters. So I'm going to pause this where it is so that you can catch up if you need to. Remember that all we've really done here is we extracted that code, we put it in something called print sequence, and again I'm just going to delete that counter code. Won't all quite fit. I'm going to reduce the output window just a little bit more. I'm going to, delete a blank line. And I'm going to document the end closing braces. So this is the end of the print sequence method. And that's the end of my for loop. So I'm just going to add a comment that says end for. Good enough. Okay, now I want to show encapsulating members of a class. In our counter class, we had one variable called counter. We made it private. Let's say we're going to add another variable. We're going to call it, max for the maximum number that the counter will reach. Now we're not going to actually do a lot with it, but let's say that I make it an int and I call it max. I give it some default value. So I've opened up the counter class. I should not have deleted that counter code over in my other file since I'm going to be modifying it again. Then I come over here back to my main method and I utilize my counter class. So here underneath print sequence, I'm going to declare my counter object. I'm just going to call it C this time. Counter C is equal to new counter. And then I'm going to set the maximum value to 20. So I type C.max is equal to 20. And then I start calling, increment or whatever. So I went back to main. I added an object that I added a reference to the counter class. I created a counter object. I referenced this member directly. And the reason I can do that is because it's a public member. So that variable is left exposed to any code that comes around. If I wanted to make that a private member of the class and add some getters and setters, that is remarkably easy to do. I can come over here to the counter, double click that. I can highlight that variable. I'm going to highlight that entire line. And then I'm going to use the refactor menu one more time and do encapsulate fields. So right click, refactor, encapsulate fields. The one that I want to encapsulate is get max and set max. Notice that I could even provide a getter and a setter for the counter at the same time. Just for grins, I'm going to do that as well. We probably really don't want the user the fellow programmer being able to set that counter, change the value of it, but we're going to give them the option to do that. Now we have checked all the individual ones. I could do select none, select all. Both of those members will now be made private. One of them already is, but it didn't have any getters and setters. Well, it does now. So our max variable, our max member, is now declared as private. And if I scroll down, I see that we have getters and setters. We have mutators and accessors for both the counter and for max. So for example, we have a method called setMax, which sets the max member equal to the argument that's passed in. And we have one called getMax, which returns the max member. Now what's really cool is that if I go back over to my main method, I see that instead of just saying C.max is equal to 20 like it did, it actually rewrote that code to say C.setMax. It changed it to a utilization of that accessor method. And so that's really nice because you could kind of scope out a class and you can put some variable names in it, some member names in it, and then you decide that you wanted those to be implemented correctly. The correct way is to usually make your data in a class private. So then you can go into that class, choose the variables, right click, refactor, encapsulate, and it will create getters and setters, the accessors and the mutators, and it will even change the code to support that. All right, obviously this is an error now because Max is now a private member. So the error says Max has private access encounter. Just out of curiosity, I'm going to go hover on the error, click on it, and see what it suggests doing. No, that doesn't look good. So don't just randomly click on the red error flags and choose whatever option it does. There's no guarantee that it's really what you want. If we gave some thought to it, we'd realize that we wanted to call setMax, and we would change that code to match. And since the line above it actually does say that, I can just delete it. So hopefully your counter class matches this one. with a get max and a set max and a get counter and a set counter and an increment counter and a print counter. Now this code is getting to be too much to all fit on one page. I'm going to take a stab at it. I'm going to delete all of the comments, which you really don't need to do, but I'm doing it to try to get it all on one page. Almost have done it, huh? If I move the braces, to this style, see, on get counter and on set counter and on get max and set max, the braces are already on the same line as the definition of the method. However, on the ones that I wrote, increment counter and print counter, they are not. So I'm going to do that now. All right, now we have the entire counter class on screen except for the documentation, the comment up at the top. So go ahead and pause it, make whatever changes you need in order to get this to compile. I guess I didn't actually ever test it after making these changes, so I may as well clean and build it, run it, open my output window. It says enter and enter. Alrighty, 10, and then it does whatever we told it to do, I'm not even sure we called print counter. I don't think we did, so we're not seeing any visible changes in it, but at least it compiles and runs. And in general, as soon as you've made 5 minutes worth of changes, you ought to go ahead and make sure that your code compiles. Because if you keep your code compilable, at any given moment, then it's easier to make sure, that whatever new change you make is what's the problem with it. Whereas if you type, for 40 minutes, you've added 100 lines of code and it doesn't do what you think it's going to do, you're not really sure where to start fixing it. And, obviously you have to fix the syntax errors first. Okay, so anyways, that's our counter class. Go ahead and make your class look like that, pause if necessary. Then go back over to the main method. Make sure it looks like this. And if you need to see the print sequence method, there it is. So looking at our itinerary, I think we've done all this. Create a project, add a class, building and compiling, adding imports, using refactor. We renamed variables, we renamed classes. We use the introduce methods by highlighting some code and right-clicking, choosing refactor introduce method, and it took all that code that was highlighted and put it into its own method. And then export a project to a zip. That we have not done. And we have not done uploading to D2L. So the last thing I'm going to do is I'm going to come up here and I'm going to try the introduce methods a few more times. So this bit about the counter, I'm going to take all 3 of those lines, right click, refactor, introduce method, and I'm going to call it do counter. It doesn't really matter what the name is, but the name kind of matches its purpose, which is to create a counter and to set its max. It doesn't do anything else, so it's a completely useless method, but here we have it, do counter. So we have this code here that says print sequence, and we have one called do counter. And now I'm going to try taking all of this code, everything from the scanner all the way down to system.out.println you entered maximum, and I'm going to encapsulate that as well. Let's see what this looks like. Refactor, introduce, method, and I'm going to call this getMax. And it worked. So now look at our main method. It is extremely short, extremely clean now. In order to get our maximum, we call a method called getMax. In order to print our sequence number, we call a method called printSequence. And then in order to execute that useless code with a counter, we call doCounter. And we see those three methods underneath it. There's one called getMax, which does all of that stuff about creating a scanner and printing out integer, retrieving it from the keyboard, printing what they entered, and returning that value up here for us to use. And here's our doCounter code, which does those three useless statements involving the counter class. And then our print sequence code. Before we turned it in, we ought to go ahead and add some documentation about what this stuff does. What does getMax do? Prompts the user for the max to count to. Whatever. doCounter uses the counter class. Except counter is uppercase C. And then what does print sequence do? Prints from 0 to maximum. Alrighty. So the top of our code looks like this. It accesses those three methods. Then I'm going to scroll down so you can see those three methods. Pause it at any point you need to in order to correct your code to look like this. There's the getMax method and the doCounter method. And there's the print sequence method. And for thoroughness sake, we'll go back and look at the counter method one more time. All right. Let's go ahead and export our code. It all works, I hope. I didn't test it. Always a good idea to test it. So I'm going to build it, clean and build, open my output window. It built successfully. I'm going to run it. It still wants me to enter an integer. Let's count to 100 this time. Yep, 0 to 100. Great. Works well. I think I'm going to close my .java files. I'll leave my itinerary open. Now, to export it to a zip file, what I do is I come over here to the project list. I wish I could make this text larger. I'm sure that I can, but I'm not going to waste time trying to figure out how. I'm going to click on the thing that says assignment 4. Now I'm going to click on the little coffee cup there rather than try to rename it by double clicking on the name accidentally. I'm going to choose the coffee cup. And then I'm going to do File, Export Project to Zip. Now this is not quite as friendly as I might wish, but it's very useful. So I'm going to export project to zip, and it's ready to export it. Unfortunately, it's putting it in some temp directory, and I don't want to have to go into appdata/local/temp or wherever it winds up on your Linux or Mac system. So I'm going to click Browse, and I'm going to choose the directory that I want it to go in. And in this particular case, I have a directory on my desktop, a folder on my desktop called Java. So I'm going to click on Desktop, I'm going to click on Java, and it lost its file name. So I'm going to call it assignment_4. And if I don't tack on the .zip, it will zip the project up, but it will not have that extension, and D2L will not accept it. So when you give it a file name, make sure you have the .zip extension. Then click Save. It has modified the path to the zip file, but it's not done until we click the Export button. We do that. And now, out in that directory, there's a zip file. So here's my desktop directory, my Java subdirectory, and there's my zip file. All nice and ready for me to go ahead and upload. And I can peek around it, I double click on it. And in my particular case, it brings up WinRAR to view it, and I can double click, and there's inside my source directory are my Java files. If I had left that package statement in there, my Java files would be inside that assignment 4 subdirectory of the source directory. All well and good. Nothing we need to change there. So that was how to export to zip, but since I forgot to bring this slide up before I did it, I will repeat the process. You certainly don't need to export it twice. But I close all my windows. I go and I select which project I want to export. I choose File, Export Project to Zip. Now I need to choose a good directory because I don't want to go to that temp directory. I choose Browse. I choose whatever directory I want to put it in. I'm going to go to the desktop, go to the Java directory. There's already one called assignment4.zip. Maybe I just want to replace that one. So I'm going to select that, not right click. I select it, I click Save. And when I click Export, it's going to warn me that it already exists. But that's okay. And it created it when RAR is opening it to show me that the new file is there. So, we're done with our assignment. Let's go ahead and upload it to the Dropbox. Now to upload my freshly made archive, my zip file of the project. So I'm in D2L. I'm going to go to the Dropbox. Click on the Dropbox, find the assignment. Assignment 4. I'm going to click on that. I need to add the file. So I click Add the File, Upload. Now I need to find that Java folder, so I click on my desktop, click on Java, wherever you stored your zip file. It'll be different than mine. I select the zip, I click Add, and then I click Submit. If I don't click Submit after I've clicked Add, then it doesn't actually complete the process. That always happens to somebody at a certain point, usually more than once per semester. Somebody asks why they didn't get a grade. I say, well, it's because this submission isn't actually there. So we click Done. Alright, I hope that was very useful. We will do a couple of other video lectures. We will actually do one for assignment 3, since it's proving to be difficult for several students. And I want to make sure that all of the concepts in it, including the array list and the two-dimensional array and the creation of a class to contain your data to put into the array list. Just want to make sure all that's clear. So, until then, see you next time.